What are some ways that we've already learned that we use fractions? Okay?
In stores.
When do we use a fraction in a store?
When you would like, when it says like 30% off, you can convert it into a fraction and find out.
Okay, so we think in fractions when Gabe said we think in fractions when we see sales, how much percent off. We know that that percent is a fraction of the whole price, right? Drake?
When you're sharing with friends, if you have one whole of a candy and you have 4 friends, you would put it in the 1/4 of a fraction and give 1/4 each person.
Okay, so when we need to share something and we want to make sure that everyone has equal parts, right? Anyone else? When else do we use fractions? How about when you were doing your Explorer cooking? Did any of you have the opportunity to use fractions when you did your Explorer cooking with your parents? Sydney?
We had to use like 3/4 with water.
Okay, so our measurements when we're cooking, right, a lot of times are going to be in fractions. So we use fractions a lot. So what I would like you to do is in your math journals, please go ahead and solve this problem. 1/2 plus 3/4. Please use some type of a model that demonstrates your mathematical thinking, your understanding about how to solve this problem. Okay? Who would like to come up and show us their mathematical thinking and how we solve 1/4 plus 3/4? Elijah, come on up.
I can do it in pictures.
Whatever works for you, whatever model you used. And tell us what you're doing as you do it.
I'm going to get 2 fraction boxes and gonna make them equal up to 4. I'm gonna color in for 1/4. I'm gonna color in 1 over here, and then for 3/4 I'm gonna color in 3/4, and that will equal 4/4. That's what I got.
All right, any questions or comments for Elijah? Drake?
I would like to agree with what you did, and I would also like to comment on what my strategy was with yours.
Okay, so why do you agree with Elijah?
I agree with his strategy because what he did is when he added the 2 boxes together, there was 1/4 and then there was 3/4. And when you add the 1 plus 3, you would get 4, and in the last box, he colored in 4 of the sticks that were out of the hole.
Any other comments, questions for Elijah? Sydney?
A question I had was, why didn't you number off like the boxes on each one? Because like for the first box, you put 4 lines, so you could have put like one was filled in, and then like the other two. Like,
So that's another strategy. So would you like to come up and do that? Add that? Thank you, Elijah. Come this way so we don't knock the cameras, okay?
Oh, wrong.
Yeah, come this way. Gabe, let's have you and Jordan just scoot this way so we have a little bit of a walkway. Perfect. So tell us what you're doing
I made
and why. So you were talking about labeling those, right?
Yeah, do you want me to label them or
Yeah.
just relate it?
No, just label.
Okay, like I was thinking you could put 1 right here, and then 1, 2, 3, and then but for the blank ones, if you wrote it up here, you could have like 2, 3, 4, so it's the ones that are left blank. And
Comments or questions for Sydney? Brian?
I would like to disagree with what Elijah did because he in his second box he only has 2 filled in.
yeah, he only has these 2.
Well, but he said he was filling in. Go ahead and fill in a little bit more for him, Sydney. And he told us that he was filling in 3 there. There we go. Thank you. So just clear. Skylar.
I'd like to like say a different way to label. So I'd like to disagree with your labeling. What you could do is you can label like the boxes 1/4, and then the next one 3/4, and then equals 4/4.
Okay, go ahead and come on up and do that. Thank you, Sydney.
The 1/4, this would be 3/4, and it would equal 4/4.
Okay, thank you. Anyone have a new strategy? A new strategy. Giselle, come on up.
How I did it was I put 1/4 plus 3/4. Then I equaled it and it equaled 4/4 instead of using the digits.
Okay, questions or comments for Giselle? Gable?
I would like to comment on yours because it said create a model, and you just did what the question. You just wrote the question.
Give me a thumbs up or a thumbs down. Is Giselle correct?
Yeah, sure.
So this is a model. What would we call this type of a model? Brian? An algorithm, right. So it is a strategy to solve it, right? It is a strategy using an algorithm. Thank you, Giselle. Did anyone have another strategy they'd like to share? Cinder?
I use pie chart. And for 1/4, I did dots to fill in. And then for 3/4, and I just did lines going down, and then I filled in 3/4 in my circle. And I could tell from me using the circle as a hole, since I filled it all in, because it filled one hole.
Questions or comments for Cinder's strategy? Skylar?
I'd like to agree with Cinder because 4/4 does equal one whole because it's 4 out of 4. So, and that shows that it fills in the whole circle.
All right, thank you. Drake?
I have a different strategy I'd like to share up on the board.
Okay, so this will be our last one. Come on up. Thank you, Cinder.
What my strategy is instead of using a pie chart, algorithm, or boxes, I actually used pictures for mine. And what I did was I did balloons, and then for 1/4 I put all of them had a line except for one, and then for 3/4 I put all, I kind of did
That's
that
okay.
one backwards. But for 3/4 right there, for 1/4 I
Go ahead and label that one then.
Okay. 3/4. And then for 1/4, I had only one with a line. And when I looked at those two together, I could tell that if I were to add that one over there, that would equal 4/4.
Draw a line for it. Connect it.
A line to connect them.
Well, to show how that you saw that go. No, the one that, because you just said I saw that this one could fill in over there. So
Yeah.
just draw that line that connects it. And so, what did you come up with for your answer?
My answer was 4/4 because all in all, you would not add the denominator in your problems you wouldn't add your denominators when you are adding fractions or subtracting fractions, but you would add the numerators together. And with this one, it gave us a regular fraction and not a mixed number or an improper fraction.
Okay, thank you. Any questions, comments for Drake? Come this way. Good?
I'd like to agree with you because if you're doing it, and if you do different strings, if you do different strings that represent each one, and if you put that string over there, it would equal the whole.
So just moving this string.
And making it kind of different sizes.
Okay, Jacob?
Would this be a ratio problem?
Well, that's something we have to talk about. So when we are looking at something like this, right, we're looking at it as a ratio of balloons that have to balloons that don't have strings, right? And so we have to decide when we are working with fractions, does a ratio make sense? Does this work with this problem?
Yes. Yes.
Using the ratio? Okay. 4 out of 4 balloons have what? Strings, right? So in this one we would be saying the ratio would be 3 balloons to 1, right? And then this one would be 1 balloon has a string to 3, and then when we look at those ratios, when we combine them, we see 4 out of 4, right? Yes?
I just noticed that with both of the demonstrations, with the balloons, that 3 of the balloons had the strings and 1 balloon had a string. They're the same thing but reversed.
Yeah. Right. So, and that's why Drake said, oh, I can see that means this can move over and connect with that. Okay? All right, so did anyone use a number line? All right, and we're not going to go over the number line because we need to move on to the next one, but we do know that a number line is another way, right? Okay. All right, thank you, Drake. a pretty good understanding about how to add fractions and what fractions mean and what they represent, let's go on to our next question. So this time we have the problem 1/4 plus 2/6. And so I would like you to solve that problem, and again, use some type of a model, choose a strategy that's going to help you show your thinking and how you solved that. Show me 5, 4, 3, 2, 1, please. Give you about 1 more minute. If you're finished, see if you can find another way to model it than the one that you used. Good. Because we've learned that there's multiple strategies, right? To solve the same problem. All right, who would like to come up and share their thinking with us? Yaneli, come on up.
For my thinking,
I did a picture, like the flowers. And right here what Drake did, I'm doing kind of the same. But then, since these are not the same, I couldn't add them up, like, to be the same, so this indicates the fourth, but this is a total of 4. 1/4. And this is like the only one that's different. And when I was gonna add to 4 the fractions. Okay, that's not. 4 and 2, 6. I noticed it all equals into 13. They're all equal 13 if we add it all up. So instead of putting 13, I put 3. And then when I added the totals, 7, 8, 9, 10, it equals 10. So I got 3 out of 10.
Questions or comments for you, Allie? Allie?
You have no picture representation for 2/6.
So, are you asking a question?
Okay.
Remember, we need to be using our accountable talk.
Oh yeah, I forgot to add something.
Any other questions or comments? Cinder?
I'd like to disagree with her answer because we're not supposed to add all of them together. We're trying to figure out what, because you need to try to find the common denominator of the 2 fractions, and then you would need to add, and then you can add them.
So Cinder just said that when we are solving, when we're adding those fractions, that they need to have common denominators. And why do we need to have, who can answer that question? Because Cinder posed the question that we had to have common denominators. So who agrees with Cinder and can answer that? Skylar?
I agree with Cinder because you can't really solve with 2 different denominators. You have to make it into the same denominator.
So why? Why can't we solve with 2 different denominators? Drake?
Actually, you could solve with 2 different denominators because unless it would go into a improper fraction, you would just end up using the higher denominator as your fraction results.
Okay, so we'll come back to that. Cinder, why don't you come up and show us your thinking? Thank you, Yaneli. And then we'll take a look at Cinder's thinking and then connect it with Yaneli's thinking and see if they both work.
So I took both the fractions. Multiply this by 6. Multiply this by 4/4.
Why are you doing that?
Because you can use the denominators and multiply them by the other fraction to find the common denominator. And this equals and this one equals 24. And then that ended up being the denominator. And this was 6/24, and this was 8/24. And I just added 6 plus 8, and that equals 8, 9, 10, 11, 12, 13. That equals 14, and that would mean I had 24 14ths.
Is that 24/14?
Oh, no, 14 24ths.
Okay. Any comments, questions for Cinder? Allie?
You could make an equivalent fraction to 14 and 20.
Oh, okay, so tell us what you're doing, Cinder.
I was doing, because I could tell what Allie was thinking.
Okay.
Right. Because like, I know what she's thinking.
Okay, so tell us what you did. How did you come up with 7/12?
I pretty much divided it by 2 because half of 14 is 7, half of 24 is 12.
So what do we call 2? He went from 14/24 to 7/12, and he said he divided it by 2, or in half, right? And half, what number represents half?
2.
2. And why did you choose 2?
Because dividing by 2 would use half of what that number is, and if you have half of it, then
Why didn't Cinder use 3? Jacob?
Both 14 and 24 are divisible by 2.
Okay, which means 2 what is its name? When we say it's divisible, it's also, when we use with multiplication, it's a what?
Common factors.
When we're multiplying numbers, Brooke, that's for you. When we're multiplying numbers, what do we call those numbers that we multiply?
Common factors.
Factors, right. So 2 is a factor of 14 and 2 is a factor of 24. Okay. Any other questions or comments for Cinder? So looking at Cinder's problem and looking at Yaneli's problem, show me thumbs up or thumbs down if you agree with Yaneli's, because we have 2 different answers, right? Yaneli had 3/10 and Cinder has 7/12. So give me a thumbs up or thumbs down for Yaneli's problem. Gabo, why do you disagree with Yaneli's problem? Thank you, Cinder.
Because with Yaneli's problem, that you're just making a higher denominator, and you can't make a higher whole number if you have 2 different denominators. So that would so that would make it wrong. And when she added, she basically just did a ratio, so her answer was incorrect because you can't do a ratio with 2 different denominators just 2 different denominators.
Okay, so let's go back to that idea that Cinder said that we have to have common denominators. We still haven't been able to answer why. Why does Janelle's problem not work and Cinder's work? Why is that? Why? Cinder said it's really important. We have to have common denominators. Why? Janelle's problem, if we look over here, do we have common denominators when she solved it? No. That's the big difference, right? Between the two. Besides, again, she was using pictures more of a ratio. So why? It obviously makes a difference, right? Look at our answers. 3/10, 14/24. They're not even close. So why? Why do we have to have those common denominators? Allie?
Because I think it was yesterday when you said you're not supposed to add the denominators, you're only supposed to add the numerators.
Why? What does that denominator represent? What does the denominator represent? Jacob?
One whole.
One whole. So if I have how many, my denominator of 4 represents what in the whole? Show me with your fingers. How many parts to the whole? So if my denominator is 4, that means my whole is in how many equal parts?
4.
4. If my denominator is 6, how many equal parts make it the whole?
6.
6. What's wrong with that? If I have 2 wholes, oh, come on. Right? 4 equal parts. 6 equal parts. Why can't I just add those denominators? Or someone had mentioned, Gabe, I think, said someone said just keep the largest one. Drake. Because Drake, if you kept the largest denominator of 6, are we still showing those equal parts of the whole? So what's wrong with this picture? Turn to your shoulder partner. Talk about it.
They're not equal. Because only if you had 2/4 and 3/4, then that would make it equal. But it would be still either fine.
Class. Yes. So as we look at this representation, this would be a denominator of 4. 4 equal parts. This represents a denominator of 6 with 6 equal parts. Why can't I just add them together? Sydney?
Because if you added them together, if you added all of it, not just the numerator, the denominator, there would most likely not be the existence of improper fractions.
Okay, so let's take a look at this a little more concretely. Okay, I have 3 friends, and I have 1 chocolate bar, and I want to share my chocolate bar with my 3 friends. Okay, so Jacob, you are such a good friend to me. I'm going to give you that big piece of chocolate. Okay, and Giselle, you are just doing such a great job. Every time I ask you to do something, I'm going to give you that piece of chocolate. And Jessie, you always come to school with a smile, so I'm going to give you that piece of chocolate. So hold up your pieces of chocolates. Which piece of chocolate do you want? Where is it mostly everyone pointing?
Jacob.
Why?
Because it's larger.
It's a bigger piece. What is the difference between these 2 parts of the whole? Thank you, Jacob. and Giselle and Jesse? Vanessa?
Because in one out of 4 the pieces are bigger, and the 2 out of 6 the pieces are way smaller.
Right? This
The
is
sizes are
the
different.
sizes are different. So when we're working with fractions, what do we see here? How many?
4.
Are the sizes bigger or smaller?
Smaller.
Compared to this one?
Bigger.
Bigger. How many pieces?
6.
Sizes are?
Smaller.
How many pieces?
24.
How many pieces?
24.
Are they different?
No.
No. So everyone's going to get the same size piece, right? That way Jesse and Giselle aren't trying to take Jacob's chocolate from him. So why then, going back to Cinder said his claim was that in order to add fractions, we have to have common denominators. Turn to your shoulder partner, thinking about what you just saw with the pieces of chocolate. Why do we have to have common denominators?
Because I found this one. It's 58 hundredths and 3
Class.
Yes.
So why? That's our big question, right? We're stuck on it right now. Why? Why do we have to have common denominators? Yes?
So everybody can get a fair piece.
So everyone's going to have a fair piece? So what if it's not chocolate? What if it's, seats on a bus? What if it's,
Daisy.
how much flour I need to add to my cake? So why? Jordan said, so everyone gets an equal piece. Vanessa?
So it can be equal, so you don't have to go to work, so it can just be equal.
So the parts of a whole have to be what?
Equal.
Equal. Turn to your shoulder partner. Why do we have to have common denominators?
So it's
It can be the same size.
All right, class.
Yes.
All right, why do we have to have common denominators? Skylar,
So it can be equal.
what can be equal? What does a denominator represent?
The whole.
The pieces that make up the whole, right? Aiden, why do we have to have common denominators?
So everybody gets a fair piece. So
Skylar, please repeat what you said.
So it can be equal the pieces of the whole.
Aiden, why do we have to have common denominators?
So the pieces are equal in the whole.
So the pieces that make up the whole are equal. Marco, why do we have to have common denominators?
Pieces are equal in the whole.
So the pieces in the whole are equal, okay? All right, who then, we have a very nice, what do we call this strategy? Algorithm. Did anyone, was anyone able to create some type of a picture that would symbolize this? And came up with the same answer as Cinder? Was anyone able to do that? Brian, come on up.
I did the same algorithm as him, but then I used a number line to show that
Oh.
actual answer.
Okay. So Brian used a number line.
So 0. And there was 12. And so in the middle would be 1.
So did you work backwards? You solved it and then found a picture representation?
Yeah.
Okay.
So I made I made 12 pieces of it, and it's 1 of 12, and then so on.
You can extend it, yeah. Go ahead.
And then, so then I just filled in the 7. And then that's what I got, the 7 of 12.
All right, questions or comments for Brian? Allie?
I would like to disagree with your labeling because on the 0 and the 12, you have them labeled like they're whole numbers and the rest are labeled as fractions.
So Allie said that the number line is written as 0 and 12 is a whole number, yet we are working with fractions. So what would this be over here? 12 twelfths, which equals one whole. Okay. Here's my question to you. Does this represents the answer? Does this represent the process to get there?
No.
No, we don't have any idea how Brian went from 1/4 plus 2/6 to that, right? Okay, so in the interest of time, I'm going to review real quickly what we went over yesterday. So 1/4, if I were to do this using a picture, here's my 1 whole. How many equal parts make the whole? 4. How many do I have? 1. Here's my 2nd whole. How many equal parts make a whole?
6.
How many do I have?
2.
Okay, so we can obviously see that those parts that make a whole are not equal, right? They're not the same size, so we need to do common denominators. Who can tell me real quickly how we can do that using a picture? Jacob, just tell me.
You add 6. All right, so you add 6 lengths to the 4 because
How do you want me to draw them?
horizontal.
Okay. So 1, 2, 3, 4, 5, 6. How many equal parts do we have now that make a whole?
Wait, I meant 5 lines, darn it. Because
No, you're fine. Yeah. Okay. So that's really not there. I'll pretend that that's just the line. Okay, so how many equal parts do I have now?
24 because 6
24.
times 4 is 24.
We have 24 little pieces, right? Okay. Now, how many are shaded in?
1, 2, 3, 4, 5, 6.
6. Okay. How am I going to then make an equivalent fraction using the bottom one? Allie?
You put 3, you put 3 lines in the 6.
Okay, so how many equal parts make a whole? Oops.
3
Not 3.
the other line.
Sorry. Gotcha. So how many equal parts make a whole?
24.
How many are shaded in?
8.
Okay. So, do I have 6 24ths represented?
Yes.
Do I have 8 24ths represented?
Yes.
Yes. Do I have common denominators?
Yes.
Are my sizes all the same size?
Yes.
Yes. So now everyone's going to get the same size, right? Jacob's not going to get the big piece, and Giselle and Jesse are going to get the little pieces, right?